Right, so let's look at a projectile motion example. So we talked about projectiles back in pre-calculus algebra. We said they follow this quadratic path. It's going to be upside down parabola because of gravity. You know, whatever we throw up is going to have to come down on Earth. And we were able to model the equation there. But now we're thinking about the parametric form, so we can think about this in terms of time. So our x is going to be modeled by v naught, v sub 0, cosine of theta t, and y is going to be modeled by negative 1/2 g t squared plus v naught sine of theta times t plus h. So theta is the angle that something is thrown. So this would be our theta value here. Okay, v naught is going to be that initial velocity, and g is going to be your gravitational force. So gravitational force, what we use is going to depend on the units in the problem. It's going to be 32 feet per second if we're in feet per second, or it's going to be 9.8 meters per second if we are in meters. All right, so let's look at this problem. We have a baseball that's thrown with an initial speed of 145 feet per second. So feet per second means we're going to use that 32 for g at an angle of 20 degrees to the horizontal. And the ball leaves our person's hand at 5 feet. So that's our height. So the parametric equations, we're going to have x equals v naught, which is the initial speed, times the cosine of 20 degrees t. Okay, remember, all of this is just a number. We could type that in the calculator, get a decimal approximation, but we want to keep everything as exact as possible. So y is going to be equal to negative 1/2 times g, which is going to be 32 since we're in feet per second, plus v naught, which is 145 sine of theta t, plus the initial height, which was 5. So I'm going to simplify that just a little bit. Negative 1/2 times 32 is going to be a negative 16. So I'm going to cheat here and type that in. So there's our set of parametric equations. X is going to tell us what's going on horizontally. Y is telling us what's happened vertically. B is asking us how long is the ball in the air. Okay, well, the ball is going to be in the air until it hits the ground. And when it hits the ground, we're talking about that vertical height. So we're going to use this equation to figure that out. So we're going to set 0 equal to negative 16t squared plus 145 sine of 20t plus 5. And we're going to solve that equation. So I'm going to go to Desmos to do that. So I'm in Desmos. I typed in my equation. Make sure you are in degree mode since we have everything in degrees. I'm having to move my window here so you can see this little thing here. So make sure you're in degree mode. And I'm going to scoot that guy back. So here's my graph, and I can pinch out and move as necessary so you can see what's going on here. We want to know when it's 0. So there's 2 places, because it's a quadratic, right? There's 2 places where that's going to happen. It's going to happen here at negative point, we'll round that to 1 decimal, negative 0.1, and at 3.2. So the question is, do they both make sense? If we're thinking about t as time, it doesn't make sense to have a negative time. So our answer is going to be this one. So the ball is going to be in the air for 3.2 seconds. Okay, another way we could do that, we could use quadratic formula and we could plug that into the quadratic formula and we would get both of those answers out. C is asking you for the horizontal distance that the ball travels. So we're going to use the fact that the ball is in the air 3.2 seconds. So horizontal distance is what's going on with the x, right? So we're going to plug that 3.2 in for t. So we have 145 cosine of 20 degrees t. So we're going to plug in 3.2 there. And I'm going to do this in Desmos. So just to get my value here. So 145 cosine of 20 degrees times 3.2. And we're going to get about 436 feet there. These asking us to find the maximum height. So let's think about how we're going to do that. If we're talking about maximum height, we're talking about vertical distance. So we're talking about the peak for this equation here. So let's go back to Desmos and look at that graph. We've graphed the y. Okay, that's what we're dealing with again. And we want to know what's going on with that peak. So the peak's going to happen at 1 second point, well, 1.55 seconds. And that maximum height is going to be 43.4 feet. So now let's graph the entire parametric equation. So I'm going to go back to Desmos, delete these guys, and we're going to graph that whole parametric. And when we graph both pieces, we're going to see how this object is moving. So 145 cosine of 20 degrees times t, that's my x. And my y is going to be negative 16t squared plus 145 sine of 20 degrees t plus 5. And I'm going to zoom out. And we know this thing is in the air for 3.2 seconds. So let's graph the entire motion here. All right, there we go. There's our quadratic. So you can see how this is moving. So here's my, starts at 5, right? A height of 5. You can see how it's moving in this quadratic like path. And you can see that this is where it's hitting the ground. And that's what we got out, about 436 feet right there. So a little shy of 440. And you can see that maximum height that's going on.